This is chapter 9.5 and exercise 1 through 12. I did a short video on this the other day covering these odd number problems, and this has to do with calculating series, and I neglected to use the formula for arithmetic series. I just went to the sigma, from the sigma notation to the calculator usage. So in this instance, I'm going to do the even number problems, 8, 10, and 12, using this formula. And the formula for the sum of an arithmetic sequence is n, which is the number of total terms, times the average of a sub 1 plus a sub n over 2, a sub 1 plus a sub n, which represent the first term a sub 1, the last final term a sub n over 2 is the average of these terms. And so to do this, I would say that we're going to write a sigma notation is equal to, I'm just going to write this out, n times quantity a sub 1 plus a sub n over 2. And in this instance, we know what our first term is, a sub 1, and that is negative 8. We know what our final term is, a sub n, that's going to be 27. And we take the average of the first and last term, that's what this is. And then what is our n? Well, our n is our 6. We can just count them. 1, 2, 3, 4, 5, 6. We have 6 terms total. And 6 divided by 2 simplifies to 3, so we have 3 times. And negative 8 plus 27, I believe, is going to be 19. So 3 times 19 equals 57. So 57 is going to be our sum of this arithmetic sequence, and we could just add these in the calculator, and we would get the same thing. Negative 8 plus negative 1 plus 6 plus 13 plus 20 plus 27. Anyway, let's go on to the next even number problem. Find the sum of the arithmetic sequence. In this case, it's the same thing that we looked at last problem. We have our sigma, our summation is equal to n, our total number of terms, times the average of our first term and our last term. In this instance, we don't know what our n is yet, so I'm just going to leave that blank. But we know our first term is 2, and we know that our final term is 70. And that's divided by 2. So for n, let's calculate n. And we find out by taking our first term, or our final term, which is 70, subtracting out our first term, which is 2, so we get 68. That's going to be the total span. And what is our d? Our d value is 2, because the sequence goes up by 2 in every successive term. So we take the 68 and divide that by 2, and we get 34. Well, is 34 our total number of terms? No, it's not, because that's the number of spans. There's going to be a first and a last, which is going to bring the total number of terms up by 1. So our total number of terms is going to be 35. So I'll put 35 in for n. Okay, that's what n is, 35. And simplifying, we're going to have 35 times, well, 2 plus 70 is 72, and 72 divided by 2 is 36. So we're going to get 35 times 36, which I've done up here earlier. We get 1260. So let's just put 1260, and that is going to be our answer right here. Next, go to our next and last even number problem, which is 12. Again, we have sigma is equal to our number of terms times the average of our first term and our last term, which is 20a sub 1 plus a sub n over 2. In this case, our first term is 111. Our final term is 27. And we divide that by 2 to get the average. And n, what is our n? We don't know yet. Whenever we find it, we're going to put it right here. So to find the n, we're going to take the span between 111 and 27. And to do that, we take 111 minus 27. And if we take 11 minus 4 minus 7, that's 4. We borrowed 1 here to make that 11, so that's going to be 10 minus 2 is going to be 8. So we have 84, total number of 84. And what is our common difference here, D? Well, it's going to be negative 3. And that minus 3, 111 minus 3. So we're going to take this 84 and divide that by 3. And we're going to get 8 divided, how many times does 3 go into 8? Twice. Right, so that's going to be 6. And we're going to bring down 2, bring down the 4. And then how many times 3 go into 24? Well, that's going to be 8. But that's the number of spans. To do that, n is going to be 1 plus that, which would be 29. So 29 is our n that goes right here. And we have 29 and 111 plus 27. That's going to be 138. 138 divided by 2 is 69. So if we take 29 times 69, that should give us our summation. So I'll put 29 times 69, and we get 2001. So going back equals 2001. I'm pretty sure that's right. I'm going to just to wrap it up, go back to do a series on the calculator. Okay, we're going to start from k equals 0 to, let's see, we have 28 spans, so we're going to go up to 28 times. What is our starting value? Our starting value is 111, and we're going to subtract 3 times k. Well, for 0 term, that's going to give us 100 and just give us 111. So let's just put this in the calculator, see if we get the same thing. I hope we do. We go to next to the 9, and we get our summation symbol. That's the second row, fourth from the right. And we're going to go from k equals 0. So we go to k equals 0. And we're going to go all the way up to 28. And we're going to start at 111. And we're going to subtract 3k. And we press that, we get 2001. So that would be a 2001 by this method with the calculator, and by this method, check. We know we're correct. Okay, that's going to be this kind of follow-up video. Hope this has been helpful to you, and I thank you for viewing.